Okay, for the example one, could you do the following? Please make coordinate B 4A 0. And could you make coordinate C 2A, comma 2B for me? And I'd like you to graph that right now. Okay, go ahead and graph that triangle right now on part A. So point B, 4A, 0. Point C, 2A, 2B. Okay, we all have a graph. Should be 4A, 0 should be on your x-axis somewhere, and then 2A, 2B should be halfway in between A and B. Okay, because it is 2A and 4A is halfway in between. Yep.
If we don't label our points on a test,
what do you mean label your points?
Like how C is, you have the label next to it, 2A, 2B.
As long as it's in the correct spot, I don't care. Like if C's way over here, then yeah, we have an issue. Okay. All right, everyone ready here? Okay, first thing I need, find the midpoints of AB and AC. Midpoint. So up above, I've already given you the formula already. All right, so let's start with the midpoint of AB, which we're going to call that point D. All right, so point D is going to be the midpoint of AB. Bless you. Do we need to use the midpoint formula here? I'm hoping not. All right, I'm hoping not. You see AB, you know what point should be halfway in between. It's already on the x-axis. So what is that point going to be here? One, what do we have? 2A, 0, yep. 2A, 0. So there is point D, 2A, 0. And then let's find point E now, which is the midpoint of AC. Now I'm going to have you use the midpoint formula, which is right up above. Add your x's, divide by 2. Add your y's, divide by 2. So what are your x coordinates for A and C? X coordinates for A and C. Here we go. 4. So 0 plus 2A, all divided by 2. And then how about the y coordinates? Let's go with y coordinates. 1 again.
0
Not minus, though. This is the midpoint formula. 0 plus 2B divided by 2. All right, let's keep going. 0 plus 2A. Okay, I'm going to write this all out. You guys can skip steps if you'd like. And then 0 plus 2B. 2B, all right. Still got to divide each by 2. So what happens here? 2A divided by 2 is just going to be A, and then 2B divided by 2. B. So there is point E, AB. And that is the midpoint of AC. Everyone all right with that quick algebra? Okay, now it's going to get a little bit more complicated. Show DE, what we just made right here, show DE is parallel to CB. Well, we got 3 formulas we're working with. Which one shows parallel lines? We did a whole entire unit on it. Which formula is going to help me show 2 lines are parallel? Cameron? Slope formula. All right, so we're going to find the slope of DE. So again, parallel, what should I come out with? What about their slopes? Is that the negative reciprocal one, or is that same slopes? Okay, so we want to come out at the end here, hopefully, if we're doing our math right, with same slopes. All right, let's go. What do you want to go first? Let's go DE. Anybody symbol for slope? M. So here's what I'm going to write. Slope, M. We're going to do it of DE first. So slope of DE. you're changing your y. So what I'd like to know are the y coordinates for D and E now, so I can plug them in. Y coordinates, 16 y coordinates. Yep, minus 0. Everyone all right? Or I could have went 0 minus b. That order didn't matter. Now, for the x's, make sure you go in the same order Maggie just went, please, when you give me the x's of D and E. Here we go, 17. Yep. So a minus 0. Did I miss something? What's the x coordinate on D? 2a. Any issues here? Okay, what do I end up getting then for a slope? Combine all your like terms that you can. What do we end up with? 20. What do we end up with? Negative a. There we go. Anybody getting stressed out now because I got letters up here? Are we okay? Yep, Cameron, go.
If you did it the other way around, would it be negative b over a?
Yeah, that's fine because it's still where the negative is doesn't matter. It's just that the slope's negative, and that makes sense. Everyone, take a look at ED. Is this going uphill or downhill, left to right? Downhill, and slopes that go, lines that go downhill of what type of slopes? Negative. Okay. All right. So let's go for BC now. Slope of BC. Give me the y coordinates in any order. Y coordinates, here we go. 12 y coordinates. 2b minus 0. Okay. Same order for the x coordinates now. I got 2b minus 0. Now for the x coordinates, 6. What am I going to put here now? 2a minus 4a. Thank you. A little bit more work here. 2b minus 0. 2b. 2a minus the 4a. They're not the same. They're not the same. So how can they be parallel? Still have to do what here? Woo, here we go. 19. Still have to do what? Simplify. 2 divided by, what happens to those 2's right there? They're gone. So I'm left with b over a, but what's 2 divided by negative 2 here? I still got that negative down there. Everyone see how that reduced? Because if here, I'm telling you, I'm going to let you know, if you keep it like this and go, oh, they're parallel, I'm going to write a note that says those aren't the same. Okay, I need you to go reduce it so I have exactly 2 slopes that are the same. Before we end it, we got to write a little statement saying how you know they're parallel now. All right, so we just proved that DE, anybody remember the symbol from the 3rd unit for parallel? There we go, 2 vertical lines parallel to BC. Because, how did we know? What's your work showing right now? Why are those 2 lines parallel? Here we go, 15. Because they have the same slopes. Questions? All right, I apologize for that cutoff. That's a part of your packet right now. I want the same coordinates being used in example 2 that we just used. Okay, so transfer them over there. I want B to be 4A 0, C to be 2A 2B. Okay, same thing. And then if you go to the next page, on page 47, there's a lot of white space at the bottom where your graph should be, but it didn't copy over that way. So go ahead and make yourself the same triangle you just made in example 1. Okay, because I want you to work all your work on the same page here. All right, so again, point B should still be 4A 0. Point C should still be 2A 2B. And sketch yourself a graph. A little bit different what I'm asking for here. I'm still looking for some midpoints now. I'm looking for midpoint of CA and CB. All right, CA and CB. We already found the midpoint of CA in the previous problem, correct? Okay, we're going to call that point D now. And what was that point? Midpoint of CA was what in the previous problem? It was AB, right? Okay, so I'm not going to have you guys do that work again. I am going to have you, though, on your own right now, is find the midpoint of CB right now and call it point E. Okay? So go ahead on your own in your group, whatever you need to do, find the midpoint of CB, call it point E. You're getting eventually 6A over 2, 2B over 2? No? 4A plus 2A divided by 2, and then 0 plus 2B divided by 2? Okay, so final point E, what do we end up with after I do all my reducing that I need to do? 6, what do I end up with? 3A comma B. Yep. Everyone all right? Point E and point D? All right, let's put them up. Let's see, point D was the midpoint of CA, so here's D, and here's E. Ready for this last part now. I want you guys to prove to me that AE, this line segment right here, is congruent to line segment BD, this one right here. What am I going to need to prove the two are the same length? Distance formula. Ooh, distance formula with variables. It's going to get crazy. Let's go. Anybody got a preference? What do you want to do first, BD or AE? AE, you got it. Hopefully they come out to be the same, right? All right, so here we go. Distance. I'll just put D for distance of AE. We know it's got the big square root. Can't do Pythag here, unfortunately. I have no numbers, just variables. All right, so subtract your x's and squared plus subtract your y's and square them. All right, A and E. Need the x coordinates for A and E so I can subtract them in any order, doesn't matter. Hey, 14, here we go. A and E, x coordinates. 3A minus 0, all squared. And how about the y coordinates for A and E? Y coordinates. Here we go, 6. B minus 0, all squared. All right, ready? I'm going to go a lot slower now because now the algebra's got to take over. Okay, what do I get here inside this parenthesis? Okay, 3A, ready? But it's not this, right? I don't want to see this written down because I have to, what's being squared here is just the A. I need it all squared. And then over here, I'm going to have B squared, okay. Keep going with me. This is something I know you did last year. I'll call your teacher up if I need to. 3A all squared. 9A squared plus B squared. Now, I know it's tempting right now to take because you see a 9, you see an a squared, you see a b squared, and you're like, all right, I'm ready to take the square root of it. But you cannot take the square root of that. Okay, here, and I'll just show you real quickly why. I know some of you may or may not be interested in this, but I want to at least show you why. If you did try to take the square root, what would you probably say it would be? 3a plus b. Everyone agree? You would say probably 3a plus b before I told you that. So if it was actually 3a plus b, the square root of that, you should be able to multiply it by itself and get what's underneath back, right? Everyone agrees? Okay, because what's the square root of 9? And if you do 3 squared, what do you get back? 9. So all I'm doing is saying, okay, if you say the answer is 3a plus b, that means I can multiply it by itself and I should get that back. All right, ready? Let's test it. 3a times 3a. 9a squared. You're like, oh, good so far. What's he talking about? 3a times b. Ooh, and then I have crickets. 3ab, right? Just stay with me. And then b times 3a, another 3ab. And then what do I get at the end? Plus b squared. Do you notice how you have a middle term here now? Those don't cancel each other out. Is that middle term here? That's why you can't take the square root of this. All right? That's why you can't. That's as far as we can go, guys. Okay, that is as far as we can go. Go, Cameron. What do you mean? Well, I already squared it. So after I squared it, there's no need for the parentheses. Okay? Good? Okay, so I'll leave that like that. Please leave it like that. All right, 9a squared plus b. I can't do anything because of the addition. Sorry, can't do it. All right, so still need to find the distance of BD now, and hopefully they match. We'll see. B and D, here we go, x coordinates. X coordinates of B and D, here we go, 16. A, yep. Everyone agree? 4a minus a all squared. And some of you are already starting to see what's going to happen, which is what we need. And how about the y coordinates? Y coordinates of b and d, 14. 0 minus b all squared. All right. What do you get inside this first parenthesis with the x's? 4a minus a? 3a. Make sure it's still in parentheses squared. What about over here? Well, negative b, right? And then what happens? You get 3a all squared, which we know is 9a squared. And what happens when you square a negative? Positive, and we already talked. You cannot, because of the addition sign, I cannot take the square root. So what do you notice? Same distances. All right, so little conclusion statement, though. BD congruent to, what was the other one? AE. Because, how do we know? 6, how do we know? Distances are equal, whichever. Yep, because distances are equal. All right. So again, the only thing I worry about is right here. Don't try to go any further. Don't try to be a hero. Can't go any further with the plus sign in between them. Questions from you guys? Okay, 2 problems tonight. 2. So if you do get done, because you have 5, 10, 15, 18 minutes left in class, if you do get done early, go right to the review, all right, which is out of the textbook as well, all right, which is on the last page of your packet. All right, so if you get the 2 problems done early, go to the review, which is also in the textbook. Let's get going.